This question is asking us to fully simplify the following expression. We have the square root of negative 45. Now we know when we have a negative under a square root, that always has to be simplified, and that simplifies with an I. So we'll take care of that first. All right, anytime you have a square root with a negative under it, take the negative out, split it up. So the square root of negative 45, we'll go through the steps here. Negative 45 is negative 1 times 45. And since it's multiplication, we can split up the square root. We have the square root of negative 1 times the square root of 45. And the square root of negative 1 is I. And you'll see that plenty. Pretty much negative inside the square root becomes an I outside, because you can see the 45 is still there. But if we can simplify the rest of it, we still need to do that. So the question is, can we simplify the square root of 45? Leaving the I out front, and we can, because 45 is 9 times 5. We have that perfect square of 9 in there. So we got I times the square root of 45. 45 is 9 times 5, so we got I times the square root of 9 times 5. We can still split up the square root with multiplication, so we got the square root of 9 times the square root of 5, and the square root of 9 is 3. So we got I times 3 times the square root of 5. Right, now this is actually fine. Once you have the square root simplified, 5 does not simplify under a square root, you are done. You can write it like this, and that's absolutely fine. Or you can rearrange it, meaning you can move the I. You can put the 3 in front if you want to put it like this. So 3 times I times square root of 5. They're all multiplications, so you can rearrange the order. Or some people even like to put the I at the very end, which is okay. 3 times square root of 5 times I. Now, one thing to be careful on this last one, you'll notice the way I wrote it. I is not in the square root because it wasn't in the square root before. Make sure you do not accidentally put the I in the square root. But that is simplifying square roots with negative numbers.